From the management page, use the New Engine filter to view the tasks or plans in which an engine is used from the Tasks or Plans pages. Enable the New Engine column to display the engine name. With the November release, Talend Studio offers you the possibility to go further with vector embeddings. The new tEmbeddingAI component, available in beta version, allows you to leverage embedding models to efficiently process data with AI. Let's take a closer look at its text embedding capabilities. The goal here is to load data about phone reviews into Pinecone. The data come from various text files like this one. To better analyze the data, and also to facilitate the search in the database later, the idea is to split the text into smaller chunks. The next step is the vectorization, with the use of tEmbeddingAI here. The chunks of data are being vectorized for later use in the vector database. As you can see, the platform used is Azure OpenAI, and the model used is Text Embedding 3 Small, but you have the possibility to pick different platforms and models according to your needs. Note that on-premises models like ONNX are supported in this component. To use this platform, you have to enter the required authentication information using your API token. And then, you choose the column to be used for embedding. The tMap component is used to verify that all the metadata are correctly transferred to the Pinecone component. Finally, the last step here is to write in your vector database, in this case Pinecone. To do so, enter your API token, and then choose the upsert operation as you want to load your vectorized data into your Pinecone index. Let's execute the job now. With the various tlog row components used inside the job, you can see the results in the Execution tab from the Run view. As you can see, we can retrieve the different chunks for each phone reviews, associated with their vectors. The tJSONValidator component is now available in the standard framework. It validates JSON columns against a JSON schema. In this use case, we are using raw input data. The purpose is to validate the content of the JSON columns in each record and split it into two categories, valid or invalid. After defining the input data, select the input column and the schema against which the records must be validated. When your job is all set, launch it and see the results in the console. Your records are grouped and you can quickly and easily see which records are valid or invalid. If you need to save the results, you can use different output components and export the categories into files or databases. You can now migrate Hadoop distributions centralized in the repository and reused in big data jobs from one to another. For example, in this job, the CDP7 distribution from the repository is used. We will migrate it to the universal CDP distribution that has been created in the repository. Close the job before migration. Right-click the Hadoop cluster CDP7 and select Migrate Distribution to from the contextual menu. The distribution migration wizard opens. In the source column of the wizard, the Hadoop cluster connection is shown with the number of jobs that the connection is reused in. In the target column, select the universal cluster and click Next. All jobs in the closed state that use the source Hadoop cluster are displayed. If the target Hadoop cluster contains the same type of connection in the source distribution, the job is migratable. You can select from the drop-down list to show all migratable and not migratable jobs. Click Next. A summary of migratable jobs is shown. Click Apply to perform the migration. The migration completed successfully. Click the Check the Report link to open the report. The report lists jobs that are migrated and not migrated, and distributions that are matched and not matched in a CSV file. Click Finish to close the wizard. In the example job, the CDP7 distribution has been changed to the universal distribution.